Welcome to this next video, guys. Today we're going to be talking about applying trigonometry. Now, for this video, your learning goal is that you can use trigonometry to find unknown sides of right-angled triangles, okay? And at the end of this, you want to be able to calculate the unknown sides of a right-angled triangle and calculate the unknown angle in a right-angled triangle. Alright, trigonometric functions. So I just want you to remember, so in our last video we're talking about this stuff, so tan of theta, sine of theta, and cosine of theta, okay? And they have functions, okay? So what that means is that thetas, different numbers get fed in. Something is done to it and then a corresponding value is fed out, okay? So remember that so this can be maybe a sine x function, and so that means that a whole bunch of x values are going to get fed in this end, and then a whole bunch of corresponding, just for the sake of it, y values are going to come out the other end, paired together as an xy coordinate, therefore ready to be able to plot. Okay. Now, in the same way as we can have these functions like a machine that works on these numbers, we can also have a function to undo the function. Okay, so you would have one that could take the y value, feed it back in, and get the x value. And you'll see later on that's something called the inverse sine function. So that's when we would get the y values, feed them through, and that would give us back the x value that generated it. So you'll see how that works. So remember, they're functions. You can play with them in the same kind of way. Do the function, undo the function. Okay, some key ideas. So when theta, the angle that's given to you in a triangle is in degrees, okay, it's important to make sure that your calculator is also in degrees mode. Okay, so the other one that you'll get familiar with a bit later down the track is you know, as compared with radians, okay? Okay, so radians is the other mode that you'll use a bit later on when we get into calculus and other sort of mathematics. Okay, now you want to choose the appropriate trig function based on the info that you have. Okay, so let's say we're looking at this triangle here. Remember, you've got, so sine, you use the sine function, so sine theta if you've got information about the opposite angle side and the hypotenuse. Okay, and you've got cosine theta is your adjacent over the hypotenuse, and the tangent of theta is your opposite over the adjacent. So depending upon what out of these information you have, right, that chooses for you which of these three trig functions you're going to use to solve your problem. Okay, so there's not necessarily a sine triangle or a cosine triangle. You look at the triangle, see what information you've got, make your decision based on that. Okay, so we can solve for an unknown angle, as I was talking before, by using inverse trig functions. Okay, so how that works is, if you've got the sine of theta is 0.5, and we want to know what is theta. Okay, and so what we would do is, first thing we need to do here is we want to undo the sine to get to here. Okay, so what we do is we're going to take the inverse sine, so sine -1 of both sides, okay? All right, and so you'll have on this side, just for the sake of it, you don't need to do this level of working, so you'll have the inverse sine of the sine of theta is equal to the inverse sine of 0.5, okay? Now, this here is similar to, so I'm just going to come over here for a sec. If I had x squared and then I took the square root of that, all I'm left with would be just x, okay, because the square root is undoing the squared function, okay, and operation. So what's happening here is that that's taking the inverse sine of the sine function, gets rid of it, and all you're left with on this side would be theta is equal to the inverse sine, theta is equal to the inverse sine of 0.5, which is equal to 30 degrees. Okay, just double check that, I'm pretty sure I'm right. Yeah, 30 degrees. Okay, so that's our inverse sine functions. We use, so inverse trig functions, use them to get to the angle that's sort of locked inside that function. So you have the same kinds of ones for, so tan has inverse tan function, and cosine also has its own inverse function as well. Okay, so you'll get a bit of practice with how to use those and where you want to use them. All right, let's have a look at some examples. So for this one here, we're going to look at calculating the unknown lengths of some right angle triangles. So the right angle triangle here, remember the trig stuff that you've got for the moment only work on right angle triangles. Okay, so first thing we're going to do is, so the first thing we're going to do is let's think about what function. Whoops. So what function are we going to use? Okay, so let's have a look at what information we've got. Here's our angle, so here's theta, right? Now, corresponding to theta, this side here is our opposite. This is the longest side, so this is the hypotenuse, okay? So, which of our three trig functions uses the opposite and the hypotenuse? So that is that sine theta is equal to the opposite over the hypotenuse, okay? So we know we're going to be using sine theta. Right, the next thing we do is we substitute our values. Okay, so we have sine theta is 46, so we have the sine of 46 is equal to the opposite we don't know, so it's actually k. My razor's not working today, so alright, so the opposite is k over the hypotenuse of 8. Okay, now once we're at this set here, now we solve for k. Alright, and so to do that, we're going to multiply both sides by 8, and we have 8 sine 46 is equal to k. Alright, so chuck that in your calculator. You can just chuck it in straight like this. Alright, you've got a sine button that opens the brackets for you and everything, and you'll find therefore that k is equal to 5.75. Okay, is that reasonable? Yep, it's less than the hypotenuse, so that kind of is making sense of what we should expect to see. Okay, alright, so moving on. So we've got another one here. So this one's a little bit different. So the first thing we ask ourselves is, what function are we going to use? Okay, and if we have a look at this one, we've got, here's our theta angle, right? And we've got on this side the adjacent, okay, the side that's next to the angle, it's adjacent to it. And over here we've got our hypotenuse, okay? No one cares about the opposite for this one here. So which of our trig functions uses adjacent and hypotenuse? That is our cosine function. So cosine of theta is equal to the adjacent over the hypotenuse. So then the next thing we do is we substitute in. Okay, and so we got the cosine of 29.6 is equal to, the adjacent is 78 over the hypotenuse d. Okay, right, so now we solve. So now I'm going to multiply both sides by d, and I get d cos 29.6 is equal to 78. Then I'm going to divide by the cosine of 29.6, and that leaves me with d being equal to 78 over cosine of 29.6. And finally, you will find that therefore d is equal to 89.71 centimeters. Okay, seem reasonable? Yep, it's larger than this one here, only by a little bit because it's a small angle, so yep, kind of makes sense. So you might be looking at that and thinking, oh mate, that's a lot of algebra. Okay, sure it is, but it's something that you'll get very, very, very familiar, very, very fast at being able to perform. Okay? All right, last one. So examples, this time we don't know our theta. Okay, so first thing first, what function we're going to use? Let's have a look. We've got theta here, and compared to theta we have our opposite, and this side we have our adjacent. Okay, so now it's the tan function that is equal to the opposite over the adjacent. Okay, and tan theta, and so we now substitute in, and we have the tan of theta is equal to 0.56 over 0.12. Okay, so now remember, to get to the angle inside the tan function, we're going to need to take the inverse tan. So take the inverse tan of both sides, and so remember that undoes the tan function. So rather than putting that giant line down there, we can sort of put theta here is equal to inverse tan of 0.56 over 0.12, and that would be equal to, so therefore theta is equal to 77.91 degrees. Okay, now so there's a lot of algebra there in your trigonometry. Algebra is just sort of an underpinning of so many areas of mathematics, and so it's super important that you practice plenty of these examples so that you become super confident with them. Okay, you've got plenty of time to go through it, and it is something that you can master. Alright, please come and see me straight away if there are some things you don't understand, or you need something re-explained, or just a little bit of help. Okay, thanks so much for watching.